In the examples workspace, one of the things that we deliver is the capability to show 3D custom line styles in our model. As you'll see in this example in the 3D model over here in view 3, we have a guardrail that we're showing that displays as a current 3D guardrail, and it also shows up in our dynamic sections. Another functionality is that when we are to plot cross sections, we would actually see this guardrail in our plotted cross sections. The purpose of this video is to demonstrate how we set this up. One of the first requirements to have in place to be able to demonstrate these 3D line styles is, of course, the 3D line styles themselves. In the OpenRoads Designer Connect edition, we are delivering 3D custom line styles in this particular DGN library called Linestyles 3D Modeling. This particular library was developed from the resource files that we deliver, and you will see each of the resource files provided in the resource backup folder. And these particular custom line styles from each of these resource files were imported into the DGN library. You can call custom line styles directly from the resource file using the appropriate MicroStation variable, but by importing those into a DGN library, it will write those custom line styles directly to the DGN so that when you allow someone else to open that perhaps doesn't have access to your resources, they'll still be able to see those custom line styles. And so that's what we chose to do in our delivered OpenRoads training workspace. And we also have a metric version of these as well. If we take a look down under the metric folder structure, our DGN library, then we have our line styles and we have our metric versions. One particular point of caution, there is one particular line style that is delivered with our training workspaces for OpenRoads Designer Connect Edition for chain link fences. I purposely did not put this one in the DGN library and give direct access to it because it is extremely intense regarding resources. So if you're going to use that one, I would use it sparingly. But you will see that we have many different ones. We have 3D pavement markings, which are somewhat special. They're actually floated above their insertion about 1/4 of an inch to allow it to not bleed into the pavements. And so we have different types of guardrails, jersey barriers, we have raised reflective pavement markers, wrought iron fences, traffic cones and barrels, etc. So we have a very robust set of 3D custom line styles that we deliver with our product. The next requirement that we have to be able to show these in our dynamics cross-section view as well as the plotting of cross-sections is we need corresponding cells that match a slice of the 3D line style. And so in this example, you will see that I have this cell library called Dynamic Excess Labels -Imperial, and there also is a metric version of this, where I have the left guardrail shown, which would impose itself on a slice of the guardrail shown in our 3D model example. And so this cell, as you see here, is shown in our dynamic cross-section view. Essentially, when we slice a 3D custom line style from our model, it's not going to show that slice directly in the dynamic cross-section view or in the cutting of the cross-sections. And so this cell is then placed in the cross-section view to exactly mimic the 3D line style that we would be slicing. And so for each of our custom line styles, you will see that I have a corresponding cell that goes along with what we would be creating from those particular line styles. And so you want to make sure that these are in place such that you will be able to then see those in the dynamic section view. The cell library in question that holds those particular 3D custom line styles is shown here. And so in our Imperial training, and also we have the same equivalent for metric, in the cell library folder, we have the Dynamic Excess Labels cell library that holds those particular cells. Now let's take a look at the requirements to hook all this up and make it produce our 3D model and our cross-section representation of that particular 3D entity. So let's examine the guardrail for the left side that we showed in our particular model. If we look at the starting of the MicroStation element templates, if I expand underneath, in this example, modeling, template points, guardrail, and barrier, I will see an element template there for an entry for guardrail single-sided left. And in particular, note that I'm calling the custom line style, the 3D custom line style that we deliver with our example workspace for that particular entity or that guardrail. And so that is the first step that we have to do. This takes care of showing the 3D line style in our 3D model. The second part to this is under the points folder structure. I have a folder called Guardrail Dynamic Excess Label. And if you take a look at the settings here, I'm calling the cell that I showed in the cell library. So here is our level and then the cell that we want to show in the dynamic cross-section view, as well as the cell that gets shown when we plot our proposed cross-sections. And so that is the two different element templates that we need to set up for this particular entry. If we take a look at our feature definitions for that entry, so if I expand down our linear category and go down to template points, guardrail single-sided left, I'm calling a linear and a point feature symbology with the same name called TL, guardrail single-sided left. That's the important call here. And so if we go down to our feature symbology for that entry, underneath linear, template points, guardrail and barrier, guardrail single-sided left, I have a default element template that is pointing to the template that draws our 3D line style, which is here. And so it's using that element template for the default, if you will. And what is called in the cross sections is our second element template. And you'll see the path there, the modeling, the points, the guardrail dynamic excess label, guardrail left. And so this entry tells it what to draw in the dynamic cross-section view, as well as when we plot our cross-sections. So those are the setup requirements for the two different element templates, as well as the feature definition and the feature symbologies. In order to see the guardrail in our example show up when we generate cross-section sheets, we need to add that to our annotation group that labels our cross-sections. And so I have entered into the DGN library that stores our levels, element templates, and features, as well as annotations. And in here, I've expanded our annotation groups. And under cross-section, there's going to be an entry called excess grid, the annotation. I'm going to manage that and take a look at what is required to see that guardrail show up on our proposed cross-sections when we sheet those. And so I have an entry here for this guardrail left. And the first thing I want to take a look at is the where field. In this particular entry, if you take a look at my settings, I'm simply telling it that to go ahead and start with all points, but to filter it down to only use these particular feature definition locations. And so I have two places where I could actually force that. One is a feature definition that is called by the templates, and the second is a feature definition that the user could use to draw it manually by themselves. And so if you choose to duplicate this feature, this is an example. But essentially, I'm saying if the point feature definition is equal to linear, template points, guardrail and barrier, TL guardrail single-sided left, or it's equal to the linear, guardrail and barrier, guardrail single-sided left, then we want to say that is what we want to label with that particular cell. Now, how did we set up this annotation? We want to annotate a cell, and the element template is going to point to the element template that we showed prior under the modeling points, guardrail dynamic excess label, guardrail left. There's no leader in this situation. The placement is just going to be an angle value of 0, and there's no text, and then we give it the name of the cell from the cell library. So the guardrail left, and that particular cell is drawn or developed at a 1-to-1 scale, so that's important, and we will go ahead and apply the active scale to that. And so that is how we have it included when we sheet out our cross sections. Then the last piece of this is to be able to incorporate points into our templates that will utilize these 3D custom line styles. Let's say, for example, I want to make this a pavement stripe on our pavement. And so if I double click this point, in my drop-down list, you're going to see I have several entries here for these 3D points. And so if I go down here to 3D pavement marking white 4-inch solid, and I select that, and notice how it automatically picks the appropriate feature definition that we showed earlier. So if I apply that, it's going to place that point there. Now, how did I do that? In the point name list here, you're going to see that I have all of these entries in, and so we go back to our guardrail, for example, you will see that it points to the correct linear template to set these up. And so I'm going to show you an easy way to take this point name list, these 3D point name list. You'll see that starts and ends at the traffic cones here, begins up at the top at the right of way, quite a bit here. I'm going to show you how you can easily incorporate those without having to manually generate these one at a time. I'm going to open up the template library, and I use a program called Ultra Edit. You can use, for example, a free program called XML Notepad, which is fine as well. But I'm going to use Ultra Edit. And in Ultra Edit, if you go to the coding tab, you can tell it to reformat for XML. And then over in your XML Manager window here, you can navigate down to the point list. And so you will see then all of these entries. And all you have to do is take all of these at the top that I started with the words 3D, copy those into your clipboard, open up your ITL, and paste those in this point list category. And it will then populate those in your ITL library without you having to go in and create each of those point names in your point name list. And so it would complete this list for you in terms of all of these 3D entries. So to show the final product in our sheeted cross sections, you'll see in this example the cell is shown on the cross section where we placed it in our template for the left guardrail in our example. And so that then is being called by the annotation group for the cross section labeling and gives us our final result.